Okay guys, now we're going to hit immunology. I love this section. It has about 13 questions and I think we can get every single one of them right. When you organize this section in your mind, you want to start with antigens and then antibodies, non-specific immunity, and specific immunity. It's as simple as that. We're going to nail those 4 categories. Think of them as like 4 separate buckets. And after we do that, you're going to be ready to rock and roll in this section, okay? So I want to start off in your text, and you can look in the first paragraph. It talks about antigens, and it says in that first sentence, molecules that stimulate the production of antibodies are called antigens. In the next sentence, it says most antigens are large molecules like proteins and polysaccharides, okay? So take a look at this past question, which showed up several times on old tests. So the take-home message, guys, is look for proteins as being the most antigenic, the most likely to elicit an immune response. Now, as you look at this visual, I want you to picture an antigen. If you've never done it this way, start now. Picture this antigen as having a specific spot on it that makes it unique. And you're going to see in the text here, it's called an antigen determinant site. Think of this like a little birthmark on the antigen that makes it unique, okay? And you're going to see later on in the lecture that T cells, I know you've heard of T cells before. T cells, do you remember what type of receptor they have on their surface? CD4, yes. So T cells with these CD4 receptors have their own individual birthmark as well. And all throughout their life, these T cells are looking for this antigen, okay? And they're looking for a birthmark that looks exactly like itself, all right? So we're going to talk more about this antigen determinant site later on, okay? Now, as you get into the next heading in our text, antigens, locations, and immune response, you're going to see the antigens are primarily found in 3 places: blood, connective tissue, and lymph. As you can see there in that first sentence, it says monocytes travel in the bloodstream, and then when they leave the bloodstream, what are monocytes called? When they're no longer in the blood, they're now called a macrophage. Yes, good. So let me show you a question that was on a past test pertaining to this topic. So the take-home message, guys, is remember basophils are not phagocytic, but basophils do, okay, increase vascular permeability. Write that down or just have that nailed in your head. They increase vascular permeability, but they're not phagocytic. If you ever see that word Kupffer cell, okay, Kupffer, stop reading the question. Just pick liver phagocytic, okay? That's one that should show up. It's been on multiple old tests. You'll nail that when you see it. Okay, guys, the next topic we're going to hit is antibodies. And before we even get into this, I want to remind you that the function of antibodies is covered in biochemistry, and you want to know the different types of antibodies. Let's take a look at this visual. You'll remember that there's IgG, okay, A, M, E, and D. It spells out gamed, right? For G, remember, it's prominent in the gingiva, okay? Make sure you get that. Make sure you also know girth. It's the most common. It's the most prevalent, okay? Be all over that on the test. You also want to know with A, IgA, it's found in tears, saliva, and breast milk, right? And you want to be really confident on that in terms of it causes bacterial aggregation, right? And it's found on mucosal surfaces, all right? And it's going to cause bacteria to not be able to adhere to mucosal surfaces. With M, you want to think IgM is made first. Okay, you're going to see later on this lecture, it's going to be the most predominant antibody in primary exposure. The first time you're exposed to an allergen, it is going to be the predominant one. Okay? You guys know IgE is going to be in type 1 hypersensitivity reactions. Any question about mast cells or hypersensitivity type 1 with histamine, anaphylactic, all that good stuff, you're going to be all over IgE. With D, not near as important, don't worry about it. Okay, that's kind of the predominant things I want you to know about structure. I'm just reviewing a little bit with you to make sure you're all over that. So guys, now as we get into the actual structure of an antibody, we want to think of it in terms of FAB portion and then FC portion. So as you look at this, remember that an antibody on the FAB portion, that's the fingerprint. That's the portion of the antibody that binds to an antigen. Okay, so you know you have antibodies roaming around your bloodstream, you have them packed in connective tissue throughout the body. When an antibody binds to an antigen, that is called an antigen-antibody complex. You're going to see that in a little bit. Okay, guys, the other thing I want to point out about antibodies is look underneath in that first paragraph. It says that they're plasma proteins. Okay, just as a reminder from histology, you want to remember that the blood is made up of 55% plasma, 45% cells. Okay, so that 55% that's plasma, remind yourself that it's essentially antibodies albumin, okay, and complement protein. So that's the plasma, the non-cellular portion of blood. Remember, the major portion of plasma is water, but that doesn't make for a very good test question. So make sure you know when you think of the plasma portion of blood, it's mainly those three things, okay? So antibodies run around in the plasma, and so do complement proteins, okay? So as you look at this structure of an antibody, you want to be reminded that the FAB portion right here, okay, has heavy and light chains. Hey guys, don't miss this, okay? You want to know heavy and light chains, that's in the FAB portion. The FAB portion is where you bind to an antigen, okay? When that happens, that antigen-antibody complex is formed. That's what it's called. Don't miss that, by the way, antigen-antibody complex. When that happens, that's going to activate plasma proteins, in particular complement proteins, okay, to come and bind to the FC portion of the antibody. So if they ask you on boards, what happens in the FC portion, you want to know that's where complement binds. It's also where one other thing happens, okay? It's also where the constant region of the antibody is called, okay? So think of it as the FC as the constant region. It only has heavy chains, okay? Whereas again, the FAB has heavy and light. So the FC, you want to think constant. You also want to think this is where complement proteins bind, okay? So again, what activates complement? Antigen-antibody complexes. Then the complement proteins come and bind to that FC portion. When that happens, that activates complement pathway. And we'll get into more on that in just a little bit, okay? Let me show you how this topic, in terms of differentiating FAB from FC, was asked on a past test. Okay guys, now we're going to talk about non-specific immunity. I love this topic. First thing you want to do right off the bat is organize it in your mind into non-specific and specific immunity. Okay, so let's look at this visual. And by the way guys, remember how we said the lecture is divided up into antigens, antibodies, non-specific and specific immunity. We've already covered the first two. So you're already feeling good right now, right? We can dominate this section, all 13 questions. So if you look at non-specific immunity, this is kind of the generic, non-specific stuff that our body does just to take care of antigens on a daily basis for us. Okay? And when you think of this, you want to think of three prominent examples. And let me show you how this was asked on a past test. So the take-home message is it's as simple as interferons, natural killer cells, complement pathway are going to be your three examples of non-specific immunity. And we're going to get into each one of those in a second. But if you look at this paragraph under non-specific immunity, this paragraph, by the way, is loaded with test questions. Okay, so you can pause and read it first if you want, or I can guide you through it. But the big thing you want to know in non-specific immunity, it says right there that neutrophils are the first to be released. You guys might remember that granulocytes, okay, are basophils, eosinophils, and neutrophils. Remember, there's white blood cells are granulocytes, agranulocytes. So on the test, they're going to want you to know granulocytes come first, and in particular, it's neutrophils. So think of the neutrophils as like the firemen, and they're going to be first to arrive at this site of injury. So let me show you how this was asked on past tests. The bottom line is if you see the word first, think neutrophils. If you continue to read on in that paragraph, you'll see that the purpose of neutrophils in that situation is to release their granules at the site of the injury, right? And if they ask you on boards, let me show you a tough question that they asked in terms of what was released at that location by the granules. So guys, you can see there, non-specific immunity is as simple as knowing that these three things are found there. We're going to cover that in a minute in the chapter verbatim, each one quickly, okay? When you think of specific immunity, that is going to be the first thing I want to tell you. First of all, specific immunity is when non-specific couldn't cover it, okay? The issue is too big for non-specific to cover it. So now we got to get more specific. It's going to take a little more time. It's more specialized. And so I'm going to talk more about this in a second, but the first thing that has to happen in specific immunity is that an antigen presenting cell has to take a bite of the antigen and show it off to the immune system. That's the first thing that has to happen. So on the test, they could easily ask you a question that says, what's the first step in specific immunity? And your answer is going to be an antigen presenting cell has to present the antigen. We'll talk more about that in a second, but right now that's the big picture I want you to know. So let's look at non-specific immunity, 3 examples, and let's get into the first one, which is going to be interferons. Okay guys, with interferons, as we take a look at this visual, what I really want you to get out of this is it's simple, okay? You're gonna nail this on the test. It keeps showing up in the same type of test question. Hey guys, do you remember the different types of hepatitis that's been throughout our textbook, A through E, right? You want to remember hepatitis C, okay, is the one that's chronic. It's the only one. So connect those C's in your mind. Hepatitis C is chronic. And this right here, interferon A, is going to be used to treat hep C. That's a big thing to know. Whenever you say interferon in your mind, I want you to say virus, okay? Guys, the next thing we're going to talk about is natural killer cells. This is another example of non-specific immunity. And remember how I said in specific immunity, the first step is what? The antigen presenting cell has to present the antigen. Wouldn't it be nice if we had a cell in our immune system that didn't require that? It could just pounce on an antigen immediately. It would be great, wouldn't it, to have this type of cell to treat cancers, right? Or to fight cancers, I should say. Yes, this is the one. So if you look in your textbook with me now, in that first bullet point, it says they do not have antigen recognition sites. And it goes on to say, therefore, a natural killer, think of it this, they kill naturally. They don't delay. They go right after things. It says a natural killer cell does not need an antigen recognition site in order to pounce on the antigen. That's a great test question, showed up multiple times. Again, we're in the category, we're in the bucket right now of non-specific immunity. Last but not least, guys, we're going to talk about complement pathway. If you look in your notes here, you guys see the heading that says antigen antibody complexes and non-specific immunity. Now, if you look at this visual again, guys, you remember that when the FAB portion, right, binds to an antigen, that's going to activate complement proteins in the plasma to bind to the FC portion. And we said when that happens, it's going to activate complement pathway, okay? Now, a real simple thing to remember about complement pathway, guys, and you can find this in your textbook, is there's a paragraph there, but the mnemonic I just made up is this mnemonic COPD, okay? COPD, to remind you of 4 different things that happens when complement pathway is activated. Okay, the first one is going to be chemotaxis. So it's going to basically draw other cells to that location. Okay, and if they get really picky on you here, okay, and they want to know what complement protein is going to do this the best, it's going to be C5a. Okay, that's really picky. That's been on multiple past tests. So write that down. That's going to be the one that's really good at chemotaxis. Okay, the next thing we want to look at is opsonization. That's another thing that complement does. The next one's going to be increased vascular permeability, okay? And it does that through the D one, which is degranulation of mast cells, okay? So when you degranulate mast cells, you know histamine's released. If there's one word I want you to associate with histamine on the test, it is vasodilation, okay? So think of all that as being, what does complement pathway do? It really goes after and directly kills the bacteria, okay, which is another D1 that you can incorporate in your mind. Not only thinking of it in terms of degranulation, but direct lysis, okay? It can directly kill the issue, the pathogen, or it can draw other cells to the location to kill it as well. So that's the big picture you want to think of with complement pathway. Now, if we got a little bit more detail, guys, you may have seen this before. Complement pathway has 2 major divisions, the classic pathway and the alternative. When you say classic, guys, a great mnemonic, if you look at this visual with me, is to think, you heard of obviously General Motors, think GM, like General Motors, makes classic cars, okay? G or M, meaning when that antigen antibody complex is formed, right, and that complement protein comes and binds to the antibody, it needs to be a G or M to do the classic pathway. For the alternative, circle that A in your mind. Alternative, you want to think IgA, okay? So it says here in our text, IgA or bacterial endotoxins, right, will activate the alternative. Now, guys, by the way, I don't really think it's essential that you know which one's classic, which one's alternative, although I think there's a good mnemonic there to help you. But the big picture I would know is IgG, M, or A are the antibodies that can do complement pathway. That's the big picture that you want to have down. Guys, so that's the big summary of non-specific immunity, is to know interferons, to know natural killer cells, and to know complement pathway comprises non-specific immunity. Okay guys, now we're going to cover specific immunity. Okay, the other name they might use on boards for this is adaptive immunity or acquired immunity. If you see any of those words, they're talking about specific immunity, okay? And you can kind of pause and kind of skim the next page if you like, but you're going to see there's a box there that talks about how T and B cells are made in the bone marrow, right? But T cells mature in the thymus, okay? And the T cell I want to talk to you about is going to be the helper T cell. And I want you to visualize this with me here on the diagram. You want to know that T cells, again, have CD4 receptors, okay? And when they mature in the thymus, what that means is they get a specific birthmark, okay, on their surface. And guys, this is kind of cool when you think of it this way. Think of it like their whole life, a T cell, and you're going to see this in the text, okay? It talks about how 1 × 10⁵ T cells actually find their antigen. Meaning, I have this birthmark on me, right? And my whole purpose in life is to find an antigen that has this exact same birthmark as what I got, right? The problem is, I'm gonna really roam around my whole life looking for this antigen, and it's most likely that I will never ever find it. Isn't that sad? I mean, its whole purpose in life, it's never gonna find that antigen, okay? And the compound matters, even if I did run across my antigen in the immune system, did you know I could literally like cross by it in the immune system and bump into it and not even know that was my antigen? Because you guys learned earlier, the first thing that you have to do in specific immunity. Let's look at this antigen here in this visual. So here's the T cell right over here. Here's the antigen. Like I said, even if they bumped into each other right now, they wouldn't even know that they were a match, okay? Because the first thing we said has to happen is that this antigen has to be presented to the T helper cell. And who presents it, guys? It's going to be an antigen presenting cell. So on the boards, if they say in the liver, you're going to put Kupffer cell, right? Yes. So you're going to get an antigen presenting cell. That's step 1. Step 2 is that the receptors, okay, on the macrophage and the T helper cell have to match. So this is kind of cool because it's always going to equal 8. So look at CD4. CD4 is the helper T cell receptor, right? 4 times 2 is going to equal 8. So you want to know, if they ask you on boards, the macrophage is going to have an MHC2 receptor. Okay, so we said step 1 is that the antigen presenting cell has to present the antigen. Step 2, we said the receptors have to match. And step 3, which I mentioned earlier, is that the birthmarks have to match. Okay, if you get all 3 of those things happening, then ding, 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 you get specific immunity. So guys, they could ask tons of good test questions just around this big picture concept of the 3 steps I just covered, okay? So what I want to get into is you're going to see, in your textbook, you're going to see a diagram that talks about what happens when the 3 things we just talked about get activated. In other words, you're going to see right here what happens, guys, when specific immunity happens. And the big picture that you'll see a lot in textbooks is that a T cell tells a B cell to produce an antibody. Now, don't lose the big picture. Remember, we're talking about specific immunity, which means non-specific immunity couldn't stop this antigen. Now we need to get more specific. So now what we're doing is we're producing an antibody that's very specific for that antigen, okay? And the way that it happens is what we just talked about. But I think in terms of test questions, when you think of a T cell telling a B cell to produce an antibody, remember, it's not just a B cell. Remember, a B cell is not what produces an antibody. It's a mature B cell, right, which is called a plasma cell, right? So make sure you remember a plasma cell is a mature B lymphocyte, okay? The other thing, guys, that I really want to make sure you get is that when you think about what a T cell does right here, okay, the T cell is now activated. It's ready to rock and roll. It's going to release a lymphokine, ding, 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 been on multiple test questions, past tests, a lymphokine called interleukin 2. Don't put 1 on the boards. Interleukin 2. And when the T cell releases interleukin 2, that's what's going to cause the plasma cells to make antibodies, but it's also going to do a couple other things. And you can see it here in this chart. You're also going to see that it causes T killer cells, right, to be activated. And it's also going to cause T memory cells to be activated. Right? So I hope when you look at this, you're like, wow, this really makes sense. I get it. I see that when specific immunity happens, this T helper cell starts bossing everyone else around. You guys have heard all your life that the T helper cell is the boss of the immune system. And on boards, they want you to know what specifically does it do, those 3 things. You also are going to want to know how does it do that through a lymphokine, which is interleukin 2. That's the big picture. Now, guys, I hope you love that. I hope that makes sense. The other thing I want you to make sure you have down in your mind is that T killer cell right there that you're seeing in the diagram. That is big time because you've studied this multiple times. You know a T killer cell has a CD8 receptor, okay? And when a T killer cell gets activated, it is what you're going to see in a couple pages in tissue transplant rejection. So if they ask you on boards, someone has a transplant rejection, okay, what's the cell involved? You're going to put T killer cell. You've also seen this T killer cell with CD8 receptors. You've also seen it as being, if you look in your text, as being the one that attacks your nucleated cells throughout the body. You probably remember that your nucleated cells throughout the body, or maybe you don't, but they have MHC1 receptors. So CD8 times 1 equals 8, just like before, right? And the third thing I think that they would ask on T killer cells on your test is they want you to know that this is the cell type involved with type 4 hypersensitivity reactions. So in pathology, okay, you're going to see that the type 4 hypersensitivity reaction is all about T killer cells. You know that's delayed, which means it's going to be activated like 48 to 72 hours after the pathogen has been elicited to the immune system, okay? So that's kind of the big picture on how to understand how to fit all that together. Okay guys, the next big topic you want to nail on boards, and this has been on literally every single test that I've seen, is to understand the types of specific immunity. So let me show you this visual here for a second. You can see that there's types of specific immunity. There's natural, and there's natural passive and natural active, and there's also artificial passive and artificial active. The test questions that they seem to go after are all about artificial passive and artificial active. And they're asking a lot of questions. First of all, understand artificial passive is all about antibody transfer. So this would be like injection of tetanus antibodies, okay? On boards, the phrase they're going to use is tetanus antitoxin, okay? So if you see that phrase, tetanus antitoxin, stop reading the question and put artificial passive. That's going to be what they're going after. If they mention the term tetanus toxoid, that is the immunization, okay? And so they're going after artificial active in that example. So it all comes down to whether they mention the term tetanus toxoid or tetanus antitoxin, okay? So pay attention to that, guys. Just pause if you need to memorize that, hone in on that. That has been literally over and over on test, and I just want to highlight it and make sure you dominate it. Okay guys, you can kind of pause and skim the next few pages. The next thing I really want to talk about is right above the heading of cytokines. We have a box about T killer cells, and I want you to hone in on that with me for a minute. I want to review that just to make sure you got it nailed. So take a look at this past test question that they've asked on this. So just as a reminder, guys, you remember with type 1 hypersensitivity reactions, IgE is the prominent antibody. With type 2, you're looking at IgG and IgM. With type 3, you're looking at antigen-antibody complexes. Remember with type 3, guys, you're thinking all the autoimmune diseases like lupus, arthus reaction. Those two things keep showing up on old tests, lupus and arthus reaction. This is more pathology review. It'll be hitting that subject for you, but I just want to give it to you one last time. When you think of type 3. Type 4 is going to be the only one that doesn't have an antibody. It has a T lymphocyte, in particular a T killer cell, which has CD8 receptors, baby. We're all over this, okay? So that's the big things I want to focus on there. Make sure you know cytokines, again, are chemical messengers. Remember that T cells release lymphokines. That's what they're going to go after, which is a type of cytokine. Okay, and you remember that T helper cells release interleukin 2, and that's what kind of gets everything rocking and rolling with specific immunity. Now, if you go down to primary and secondary exposure, I mentioned this briefly before. The key thing you want to know is the first time you're exposed to an antigen, which antibody is produced first, guys. It's going to be IgM. IgM is made first, remember? Whereas the second time you're sick, it's going to be IgG. Good, okay? That's the key things you want to know from that. Okay guys, now as we look at tissue transplant rejection, that heading, you're all over this. You already know this is type 4, you know it's delayed, you know it's T killer cells with CD8 receptors. You also know, as you look at this, the prominent example would be like tuberculosis skin test. Poison ivy would be another example. And you're going to get this again in pathology. One last point I want to mention though, this is a review. Remember if you see the word hapten, H-A-P-T-E-N, if you see that word, you want to think on the test type 4. That is a molecule that's so small it will not elicit an immune response on its own. So think of it like poison ivy. It's a small molecule, gets inside your skin, and it's not until that small molecule binds to a carrier protein that it will now elicit an immune response. That's hapten. If you ever see that word on boards, stop reading the question, pick type 4 or pick the cell, which is going to be T lymphocyte, and you're better than that because you know it's not just a T lymphocyte, it's a T killer cell. Boom. Okay, good job, guys. Okay, guys, as we get into the last heading, which is tumor immunology, I want you to hone in on natural killer cells one last time. You already know they do not require what? They don't require an antigen presenting cell. Good. That's the bottom line thing I think you should definitely know. The other thing is obviously it's a component of non-specific immunity, one of our 3 examples, right? But let me show you a difficult way this was asked on a past test. This is a cool thing you want to remember in case they ask you like a top 1% type question. So the take-home message is, even though you want to think of natural killer cells as being an example of non-specific immunity, which it is, it can cross over and influence specific immunity, okay? That would be a really hard test question, but I think now that you got the category straight in your mind, you can easily remember that for the test. As you get into the last section, which is looking at blood test, I want you to pay attention to CBC, okay? You guys know that CBC looks at the cellular portion of blood, which is going to be red blood cells, white blood cells, platelets. You guys know that red blood cells are the most predominant cell type. 45% of your blood is red blood cells. You know the white blood cells are only 1%. If they ask you about white blood cells, what's the least common? You're going to pick basophils. Yes. You remember that mnemonic in histology, never let monkeys eat bananas, which is totally stupid, I know. But basophils is the least common. The never at the top is neutrophils, which is the same thing as PMNs, right? They're going to be the most common. So pay attention to that in case they ask. When it comes down to it, guys, the only other thing I would know at the end of this chapter is ANA test, the ANA. I would know that the ANA test is for autoimmune diseases. And the classic example that I would expect to show up, and it has shown up on multiple tests, is that that's going to be type 3 hypersensitivity reaction. And you want to know lupus, okay? Lupus is your predominant example that they're most likely to ask. All right, guys, that's it. Hopefully that was quick and easy and efficient. 13 questions. I want to wish you the best of luck on this section. I genuinely want so badly for every single one of you to nail this test. And it's taken me a long time to kind of piece those things together in a way that hopefully is logical and efficient for you. So go get them, go dominate that section, guys.